Welcome students, welcome to part 3 of chapter 2 structure of atom. So in last video we have discussed about Thomson model of atom and now we are discussing about the Rutherford model of atom. Rutherford model atom is also known as the alpha particle scattering experiment. As we know, alpha particles are doubly charged helium particles. So whenever these helium particles or say alpha particles are bombarded over the thin gold foil, which was studied in the 9th class also. So the same experiment, same conclusion is there, but it will conclude the more elaborate concept. So let us start. Very first is Thomson model of atom and the second is Rutherford model of atom, or it is also known as Rutherford nuclear model of atom, or it is also called as alpha particle scattering experiment. So along with the Rutherford, the two students of him as Hans Geiger and Ernest Marsden performed an experiment called as alpha particle scattering experiment. So in this experiment, he bombarded high stream alpha particles over a very thin gold foil. Says about the diameter of this 10 raised power minus 10 raised power 2 nanometer, means around 100 nanometer, which is very thin in diameter. So Rutherford bombarded a stream of high energy alpha particles from the radioactive source over a very small or very thin gold foil having a circular fluorescent zinc sulfate skin around it. So you just take a very thin gold foil which was surrounded by the zinc sulfide screen. So what happens when he just take alpha particles from a radioactive source and these alpha particles are bombarding or colliding with this gold foil. So he just observe some observation we will discuss earlier. So the observations of this experiment or alpha particle scattering experiment is as very first is that whenever the alpha particles are striking on this gold foil with very high speed, so most of the alpha particles pass through the gold foil undeflected, means most of the particles are passed as it is without showing any deflection. And the second observation is a small fraction of alpha particles were deflected by very small angles, means whenever the alpha particles are striking to this gold foil, so these may show very deflection of very small angle. So this is the second observation. But the third one, which is the amazing observation, or which is what the unexpected observation, that a very few alpha particles, say about one particle out of every 20,000 particles bounce back, that is the deflected by 180 degree angle. Means whenever the particles out of every 20,000 particles, the particle after striking the gold foil is bounced back in the same path. This is the very amazing observation observed by Rutherford. So this will decides the property, another property of this model of atom. So according to these three observations, what he concluded. So the Rutherford concluded that most of the space in the atom is empty through which the alpha particles are passed through without showing any deflection. Means whenever, for example, if we are taking an example of an atom which is taken as, wait a minute, I'm just clearing the space. For example, this is a atom and most of the space is empty, so the alpha particles are passed straight as it is without showing any deflection. This is the first conclusion of the space. And the second thing is what a few positive charge particles were deflected due to the presence of the positive charge clouds separately spread here unevenly. Means what, according to him, whenever the space is occupied by positive charge particles, say about protons, and the alpha particles which are again the positive charge particles, so due to the force of repulsion or the repulsive force existence, these particles will show the some deviation by small angles. So the deviation by small angles is observed only when the alpha particles strike with the positive charged particles, that is the protons, which is unevenly spread through this atom. The third one is the volume occupied by the nucleus is negligible small or negligibly small as compared to the total volume of the atom, which is the very third observation, that is the one atom out of every 20,000 atom is bounced back, as we know that it is the alpha particle which was striking and the nucleus which containing the neutron. So by hitting with the neutron, the particle is bounced back by angle of 180 degree. So this describes that the volume occupied by the nucleus is very small as compared to the volume of the atom. So we can say that the volume of atom is very large as compared to volume of the nucleus, or we can say the mass of the atom is considerably present in the nucleus of the atom. This is what, if you compare the radius of these two, that is the atom and the nucleus, so radius of atom is around 10 raised to minus 10 meter and radius of nucleus, that is around 10 raised to minus 15 meter, which is what, very small as compared to size of the atom. So about this conclusion, Rutherford put forward some postulates about its model of atom. So very first postulate is the positive charge and most of the mass of an atom was densely concentrated in extremely small region, which is called the nucleus. As I told you in the previous point, that the mass of an atom as well as the positive charge of an atom is considerably present in the very small region, which is termed as the nucleus. Means in an atom, the very small region which is consisting of the positively charged particle, that is say about the protons, as well as most of the mass, which means what, along with the neutrons, is consisting in the small region called as what, the nucleus. And the second thing is what, the nucleus is surrounded by electrons. Means around this nucleus, the electrons are surrounded in a fixed path, or which is what, a circular path in which electrons are revolving around this nucleus with a very high speed, and this circular path is known as the orbit. So the nucleus surrounded by electrons that move around the nucleus with very high speed in a circular path, which path is known as the orbit of this this atom. The third one is the electrons and the nucleus are held together by electrostatic forces of attraction. As you know that the nucleus consisting of the positive charged particles, that say about protons, and this orbits consisting of the negative charged particles, say about the electrons, and there is existence of positive charged particles and negative charged particles, a kind of force called as electrostatic force. So this electrostatic force is responsible for the existence or this neutrality of this atom. So this is the concept of Rutherford model of atom, which describes the electrical neutrality and the position of electron, or say about the exact position of electrons around the nucleus. So this is what all about the Rutherford's model of atom. Thank you so much.